I had to decide in which language I speak here. I speak many languages, all equally bad, but if I couldn't do it in Italian, I thought it was almost an insult not to do in English, because why in Spanish, or why in French, or in Basque, it will suppose for you quite an effort. So I choose to do it in English. Not that I speak English with a very good accent. In fact, I've been a student in Cambridge. I am Doctor of Science, is a mini honorary doctor by Cambridge, but my accent is not very good. In fact, when I finished in '76 my PhD, I was invited to give at the Cavendish laboratories, the place the electron was discovered, the neutron was discovered, and the structure of double helix of DNA, to give a seminar. At the end of the seminar, one of the legends of physics of the 20th century stand up and said, "Pedro, where did you learn English?" Being a young arrogant, I say, "In Oxford, sir," and being in Cambridge. And he said, "Did you ask for your money back?" Then I am not appearing in front of you with a great credentials about my accent. But being Basque, I thought that speaking in Spanish here in Italy will not be appropriate. So English is the common language of science, and I choose to do it in English. But I would like to express my gratitude first with a few words in Italian, to say that I am fiero di essere ricevuto come membro straniero in questa illustre accademia. So thank you very much for accepting me. And there are some Basques who have come from San Sebastian to accompany me, so I thank you for arriving in time. That is a novelty. So when thinking about how to begin this talk, I was reading the talk that Henry Rowell gave at the end of the 19th century as president of the American Physical Society. In that speech, Rowell asked himself, why, when the doctor comes to visit me, he can only say that my beloved wife, my dear daughter, are going to die. This speech is especially moving because he died 18 months after of diabetes. The remedy for insulin was discovered 20 years later. And he answered himself, being very clever. So the answer is ignorance. Ignorance as a source of problem. The remedy is still unknown. This Rowell was quite a character. When testimony in front of the Supreme Court of the United States, he was asked by the judge, who is the best physicist in the United States? And he answered, myself, I am. That was, considering his university a little too much, and was taken challenged in returning to the university. But how can you be so arrogant? And he said, because I was under oath. I had prestato giuramento. But being a clever guy, he asked himself, but with the advance of knowledge, can I expect that a father at the end of the 20th century will not be suffering like I am suffering now? And the answer is yes. This is exactly what has happened. The 20th century is the century of the triumph of the success of science and technology. Technology has reduced our dependence on the natural environment, on pain. He has made our life longer. Bertrand Russell said that almost everything that distinguishes the modern world from earlier centuries is attributable to science. Science has played a humanizing role in society. Because of that, when I hear science, the first word who comes to my mind is future. Future is the word that science brings to my mind. I believe some science and research mean the future. Here we have the... This was always like that, because already in 1898, William Crookes wrote that all civilized nations stand in a deadly peril of dying because it will not be enough food. And he was right. But it was chemistry who came to the rescue with the cycle of Haber-Bosch synthesizing the fertilizer, synthesizes ammoniac from nitrogen, who has a very big, very strong chemical bond, quantum bond, and a hydrogen. This is the giga saver of humanity. The discovery of Haber and Bosch has saved the life of millions. And nowadays, half of humanity, almost half, 4 million people live thanks to this technical discovery. The same one, incidentally, Haber, who developed the toxic arms for the First World War, and his family was killed. So this is, now what is science? Of course, I'm not going to define, because this is a very clever audience, but very heterogeneous, to come into philosophical aspects of what is science. But science, against what most people think, is a rebellion against authority. It's a rebellion against authority. Because of that, it cannot be learned like a method or a recipe. The only way to learn how to do science well is by doing with the ones and next to the ones who do it well. And for that, the schools, the lineage, are very important. It's very decisive, the geographical anchorage of science. But science, above all, is empiricism, experiment. The motto of the Royal Society, society of comparable status of the Lombardo Institute, is nullius in verba. It comes from Horatius, I think, nullius addictus jurare in verba magister. Don't pay any attention to authority. Experiment is the only judge of the scientific truth. But sometimes the success of instrumental aspect of science is so great that we forget that science, above all, is knowledge and is the critical and essential part of humanities. I don't like this, I apologize, this humanities and science. Science is an intrinsic part of the humanities heritage. We learn it from the Greeks and should be kept within the humanistic view. Because, in my opinion, the conceptual structure of science is the most important collective cultural work of mankind. Perhaps, if you are able to understand it, it's perhaps the most beautiful collective work of art of mankind. All the questions that in the past were asked by the classic, by the philosophers, now they are being answered in the where are we coming from, what is the origin of everything, what is the reason of the diversities, are being answered in the labs of physics, of chemistry. Of course, science is based in a faith. It's a curious thing, but science is based on a faith. The belief that we can understand. There is no scientific proof that the world can be understood, and even less that our mind can understand it. Of course, the success of the past justifies the faith in the future. But let me summarize 3 points that I consider beautiful, important to define what beauty is for me in science, and that are important in science. First characteristic is the long term. Science is progress. Science is a collective work. L'art, c'est moi, la science, c'est nous. Science is us. Art is me. art is a personal creation, while the essence of scientific activity is the discovery of a reality which, if not made by one, is made by another. We will not have the Mona Lisa without Leonardo da Vinci, but we will have the structure of DNA in a matter of time. It was only a matter of time before the structure of DNA was discovered. No? Because of that, because this progress, because we work together on the shoulders of the giants, of the ones before, science requires a long-term policy. When COVID came, the countries who react first were the countries who had a big scientific basis, because it is immense, the quantity of knowledge that was required to go into the vaccine. We should not forget that when we listen stupidities, even if the stupid who says that is the president of a big country, but science is not a respect of authority. And this is nothing that can be improvised. And when a pandemic case comes, can be solved with a big inversion. This requires long-term policy. The second characteristic of science is creativity. Above all, science is creativity. And at the moment, there is a tendency to direct science, determining the strategic direction that research should follow, making it, it is said, to follow the needs, the immediate needs of the market or of the health. No? Politicians, industrialists, wealth and health right now, and we have to work on that. Let me go against this tendency by telling you a beautiful story that was told to me by Max Born, by the son of Max Born, one of the creators of quantum mechanics, the professor of Heisenberg, the professor of Dirac, and professor of many other scientists. He got the Nobel Prize in '54. All his students got the Nobel Prize in the 30s. It's not bad that the professor gets the Nobel Prize much later than the students. That is the signal of a great professor. And he told me a story that the president of a big company had tickets to go to listen to the Schubert Unfinished Symphony. Since he couldn't go, he gave the ticket to the director of personnel. Next day, he encountered the director of personnel at the business and asked him, how was the concert? And the director of personnel told him, you will have my report tomorrow morning. This got surprised the president of the company, who went next day very fast to his office to find the following report about the Unfinished Symphony of Schubert. For considerable, well, you can read better than, but I can pronounce it. For considerable periods of time, the four oboe players had nothing to do. Their numbers should be reduced and their work spread over the whole orchestra, thus eliminating peaks of activity. How a bureaucrat is analyzing a creative act. He continues, all 12 violins were playing identical notes. The staff of this section should be drastically cut. If a large volume of sound is required, this could be obtained through an electronic amplifier. Much effort was absorbed in playing the demi-quavers. It seems an excessive refinement. It's recommended that all notes should be rounded up to nearest semi-quaver. If this were done, it should be possible to use trainer and low-degree operatives. No useful purpose is served by repeating with horns passages that have already been handled by the strings. If all redundant passages were eliminated, the concert should be reduced from 2 hours to 20 minutes. And finally, telling you that Schubert would have been lucky enough as to attend to these matters and have a director of personnel like you have, he will certainly have time to finish the symphony. This what tells us is that in research, as in music, blind bureaucracy has the effect of destroying imaginative creativity. If it is truly valued, it should remain free from bureaucratic excesses. In research, the essential key for success is freedom. Freedom is an essential requirement for creativity. My message is that more important and even more profitable than regulation and fixed targets to science is create an atmosphere, a kind of environment in which creativity can freely flourish. And that should be the main message of this part of the talk. The sublime usefulness, the sublime utility of useless science. Freedom is more profitable than regulations and fixing targets for human thought. Here you have something that I got from courtesy for Sheldon Glashow, Premio Nobel de Física, in which he expresses discoveries in medicine, fundamental science, who have transformed in practical uses. For example, it's fantastic that the antimatter, the discovery of the positron, can be translated. The antimatter, that is nothing, the nothing can be translated into a tomography of positron. I think this is a beautiful thing. Or the lasers, I will come lasers. The laser was called a solution searching for a problem. And now it's an industry in medicine all over the world. No? Medicine, for example, you could have in information technology the same. All these discoveries, but two, together with the ones before, got the Nobel Prize. For example, in my own work, some work that I have the pleasure of sharing and doing together with Professor Giorgio Benedek, I have used the laser, we have used the laser experimentally to follow the electrons in real time, in times of femtoseconds or attoseconds. Femtosecond is 1,000 of 1 billion, Spanish billion, 10 to the minus 15 seconds. An attosecond is 1 million of 1 million of a million of a million of a second. And this is important because we can improve, reduce the damage in electron microscopy and understand all this time. We can understand the contributions to the decay in times of electrons due to the interaction with other electrons or with the interactions of the vibration of the lattice, the so-called quantum phonons, in which the world expert is Giorgio Benedek. And it has been a pleasure to collaborate with him. In fact, we got some, for a scientist it's very important to get a cover of Science, a cover of Nature, and the first work that I did I did with the Germans and with many others. We got the cover of Nature. No? And when we study not only how the electrons runs, but how the electron dance, depending on the angular momentum, we thought that we were going to prepare and to have the cover of Science as well, and submit this kind of dancer to be the cover, but unfortunately, Science select a pig, a pig genetically modified by CRISPR. So once, not only is always one. And now I go to I've been told by the president in a fantastic lunch that I should be brief. I don't know if you understand, things run faster than if you don't understand. No? And I don't know how, I will try to measure my talk in measures of units of seconds, not in units of Italian politics or whatever, as I have been listening before. And go to the beauty problem of science. What is beautiful in science? I want to express to you what is beautiful for the physicist, or at least for one physicist like me. One physicist has dedicated his life to quantum physics, to physics of condensed matter. Of course, when we see these beautiful images of the universe, the magnificent accelerators who allow us to dwell and to deal into the inner constituencies of matter, like the Higgs boson. Of course, that's fantastic when I see the astronomy and see the planets, but I'm not going to talk about that. I'm talking about what it is, the inner beauty, the intimate beauty, what Oppenheimer, Lord Poincaré calls the intrinsic beauty of science. What makes Oppenheimer says, when he sees the solution of Ulam for the implosion of the hydrogen bomb, to say, in spite of technical aversion, ethical aversion, that is technically sweet, changes his view about the hydrogen bomb, and an aesthetic view makes change his ethical views. Technically sweet, how to begin the hydrogen bomb with an implosion of a small atomic bomb, who makes the matter compress so much that the nuclei can get together and produce the nuclear fusion. No? Or what makes Dirac says that the laws of physics have mathematical beauty. Or el propio Weil, who has worked so much in symmetry, tells that forces to choose, I will choose beauty before truth. This sentence is a scientific stupidity, but it has created a lot of attention. No? Or Heisenberg, practically in ecstasies when he understood in an island near Denmark the unity of quantum mechanics. Incidentally, last week was the anniversary of that event. Or Watson, who discovered the structure of the double helix in Adina in Cambridge, when he stand up to talk about the double helix, and he was so drunk after the sherry at the beginning and the port later, he couldn't articulate a word and had to sit down. But he said before sitting, but it's so beautiful. What is this makes science really beautiful? No? Of course, there's the beauty of the equation. There's the Maxwell equations who codify the magnetism and electricity from the long waves to the gamma rays. And these equations, for the ones who can understand, are really beautiful. And this beauty derives from many sources, from the very way they were discovered, from the very shape, and from the power to inspire author to good ideas. No? Makes Boltzmann, by looking at them, said, quoting Goethe, it is perhaps a God, the one who has written these equations. Or when I see the equations of the general relativity, in which matter and energy are put together. No? The matter tells the space how to bend, and the space tells the matter how to move. This theory, Einstein said, and I agree, is incomparably beautiful, but it's not easy to understand. Max Bohr said, the theory of general relativity appeals so much to me, it is a work of art. Or the equation of the relativistic equation of the electron, who is beautiful because it encompasses a secret of nature, antimatter, who now we use in medicine. It is the triumph of reductionism. In fact, it's the triumph of symmetry. How nature, reality, through the conservation laws, are related to mathematical beauty through symmetry. But of course, appreciating beauty in chemistry or in biology is not the same. It is harder. It's more difficult because chemical and biological processes cannot be boiled down to a simple looking equations. And look at this another kind of beauty. Look, the isomers of pentane, for example, C5H12. There are 3 isomers. Isomer is más o menos the same. Something that is the same as other. But if you go to C30, there are 4 million isomers. And look and think of hemoglobin. Billions and billions and billions and billions of possibilities, because only carbons are 2,954. And this marvels about the selectivity in the body's synthetic machinery that evolves to just 1 isomer, in which hemoglobin, to do what hemoglobin has to do, that is to bind oxygen. And this one message of my talk, the beauty of reductionism can be complemented by the beauty of emergence, the emergency of new properties due to interactions, properties that are consistent with the constituents but cannot be explained by them. But now, having said that, what, in my opinion, the criterion to define if an idea in science, if an idea is beautiful? The first one is how broad and far-reaching are the implications of that idea. Think of evolution. The other one is how subtle and unexpected are the connections. The third one is how deeply does it penetrate into the secret of nature? Because science is the knowledge of reality, not speculations about mathematical constructions. No? So the concept of reality. And the fourth one is simplicity, to contain the maximum information in a minimum set of equations or ideas. Occam's razor, if you want to see. It's a useful and beautiful idea. And for me, it's very beautiful, the collective character of science. No? Science increases advancing knowledge, discovering new things. But the biggest contribution of the advance of knowledge is the advance of ignorance. The more we know, the more we discover things that we don't know. And it's like in a circus, when the light is small, the mystery surrounding it is small. But when you increase the light, you increase also the mystery. Expanding the frontiers of knowledge brings us into contact with the unknown. The biggest contribution of the advance of knowledge is advance of ignorance. This was beautifully said by Faraday. The great beauty of our science is his advance, in some degree, opens the doors to a vast and diverse knowledge, overflowing with beauty and utility. With this criterion, the evolution theory is beautiful, of all the connections, explanation. The Maxwell equations are beautiful because codifies the whole of electromagnetism. The relativity theory is beautiful because unifies space and matter. The Dirac equation is beautiful because, as I said, it reveals a crucial secret of knowledge, whose existence we didn't even suspect. No? These, I think, are the real criteria. And the next question should be, as it has been said, is beauty a criterion for truth? This is what John Cage said. Beauty is truth, truth is beauty. That is all we know on earth and all we should know. This is a tremendous sentence. Because if truth is the criterion of, if beauty is the criterion of truth, the string theory should be true. One of the greatest minds of the 20th century have said that. Superstring theory is too beautiful to be wrong. I think this is wrong. The only criterion of truth, as Faraday again said, is experiment, is contracts with nature. To become nothing is too wonderful to be truth, to be true. It has to be consistent with the law of nature. An experiment is the best test of such constituency. Not always you can have an experiment. We cannot reproduce the initial conditions of the universe. It will require accelerators of the size of our galaxy. We cannot do this experiment. And in that case, one has to favor elegant models. But I think in the last years, we have gone too far in the things that favor elegant models to the detriment of accuracy. Not only in physics, also in economy. Paul Grumman said, economists mistook beauty mathematics for truth, or in other fields as well. And just to finish, because it is the moment, delicate moment for a speaker, the moment in which he is so grateful for the immense attention that I am detecting in this generous audience, that his wish to continue can be inversely proportional to the wish of the audience for him to continue. But I don't want to finish without saying that the biggest challenges of mankind, energy, health, food, water, balance with nature, inequality and increase of intolerance and fundamentalism, will not be solved with less science, but with more science, but also more education and more knowledge in other fields of humanity. And we have, the scientists have a special duty, as I know that you do, to explain society what we do and why we do it. We do it in the Donostia International Physics Center with many things. One of them is passion for knowledge. Science, and we have the duty to explain that science is an adventure. It's an adventure, essentially artistic, with a discipline and overflowing imagination, based on faith on the reasonableness and beauty of the universe of which we are part. And if we don't use science to apply new remedies, we must have new evils, and that was said a long time ago. Finally, science is not a frozen body of dogma, but an intellectual adventure, a human adventure. And science, core part of humanities, is economically decisive, culturally crucial, and aesthetically and intellectually beautiful. It's not a frozen body of dogma, but an intellectual adventure, a human adventure. But it's not all science. And for that, institutions like this one are very, very welcome, the Lombardo Institute, because there is more than knowledge, it's wisdom, and we should not forget what Eliot said in the chorus from the rock. Where is the wisdom that we have lost in knowledge? And where is the knowledge that we have lost in information? And for that, I insist, not only institutions like the Lombardo, but the ones who have made the Lombardo institution great should be remembered, because I love this sentence of André Gide, all the waves of the sea own the beauty of the profile to those that precede and retreat for them. When the waves came, the next beauty, the next wave requires the destruction of the one. And that institutions like that are based on the work of the ones who do it before. I was very happy to hear that we are going to pay homage to a man of 95, Ingeniero and Professor Saki Landriani. I said it okay? So is this sentence from Gide is the best way I have to join myself in this homage to your earlier president. And with that, I finish with grazie mille.